Hello all, in this video we will learn about force, terminal velocity and momentum. Rest and motion. So what is rest? When we say that a body is in rest, a body is said to be in rest if it does not change its position with respect to its immediate surrounding. A book lying on the table will not change its position with respect to its immediate surrounding, that may include walls, table lamp and so on. Similarly, a bench fixed in a garden and the chairs of dining table are at rest as they do not change their position with respect to their immediate surroundings. A body is said to be in motion if it changes its position with respect to its immediate surrounding. Like a moving car changes its position with respect to its surroundings, so the car is said to be in motion. Rest and motions are relative terms. A body may seem to be at rest with respect to one object but may appear to be in motion with respect to another object. If we consider a passenger in a moving train, the passenger is at rest with respect to his co-passenger. But the passenger is in motion with respect to an observer standing on the ground. So to change the state of rest or motion, a force is needed. Force as a push or a pull. Force is defined as a physical cause that changes the state of rest or the state of motion of an object. A body is considered to be pushed away when we apply a force to move it away from us. Examples: if a car does not start, we push it to make it move. The pedals of bicycle have to be pushed to move it in the forward direction. And a body is considered to be pulled when we apply a force to move it toward us. Examples: to move a luggage trolley, it is pulled by the pulley, and we pull a door to open it. So from these examples, we can infer that at least two objects must interact for a force to come into play. Forces can be divided into two types: contact force and non-contact force. What is a contact force? A contact force occurs when an object or a material that exerts force touches the object or material on which the force acts. So muscular force, impact force, mechanical force, strain force and frictional force are examples of contact force. In muscular force, when the force applied by the muscles of a human or an animal body is called muscular force. Impact force, when a moving object collides with another moving or stationary object, an impact force is exerted by one object on the other. Mechanical force, when a body moves with the help of a machine, the force exerted by machine is called the mechanical force. Strain force, when some materials are squashed, stretched, twisted or bent, they exert a force that acts in a direction opposite to that of a force acting on them. So these materials are called elastic materials, and the force that they exert when they are deformed is called a strain force. Frictional force, the force of friction acts when one surface moves on another surface, and the force opposes the motion between the two surfaces in contact. Non-contact force. A non-contact force occurs even when an object or a material do not touch each other. These forces act on a body from a distance. Examples are magnetic force. When we bring a magnet close to iron nails, they get attracted toward the magnet. Clearly, the magnet has applied a force on the nails, although there is no direct contact between them. So this force which is exerted by magnet is called the magnetic force. Gravitational force. There is a force between any two masses in the universe. The masses may be small, such as those of an ant and a pebble, or they may be very large. So the force that exists between any two objects because of their mass is called the gravitational force. The gravitational force of attraction depends on the mass of the body. The force acting between small masses is too weak to have any noticeable effect on them, but the gravitational forces between two large masses such as Sun and Earth is large enough to be very important. So it is the gravitational force between the Sun and all planets in the solar system that holds the planet in their respective orbits. Effect of force. We cannot see a force, but we can see what it does. We can also feel the effect of force on our body. So force can move a stationary object. A force applied on a stationary object can make it move. Force can stop a moving object. We can stop a moving object by applying a force in the direction opposite to the direction of motion of object. Force can change the speed of a moving object. A force applied to a moving object can also change its speed depending upon the strength and direction of the applied force. Force can change the direction of a moving object. If we apply force on a football using our foot, then the direction of motion of the football changes. Force can change the shape and size of an object. When we press a balloon filled with air, the shape of the balloon changes. Force produces acceleration. And another important property of force is that forces always act in pairs. We will learn in detail in coming slides. Resultant force. If two or more forces simultaneously act on a body, then the total force acting on the body is called resultant force or net force. Each force is represented by an arrow called as a force arrow. And the length of the arrow represents the magnitude of the force and the arrowhead represents the direction of the force. Here, when two forces or two or more forces are applied on an object in the same direction, then the resultant force acting on the object is equal to the sum of all the forces. Here net force is 4 Newton plus 7 Newton since both these forces are acting along the same line, along the same direction. The box will move to the right. When the two forces are applied in opposite direction on an object, the resultant force is equal to the difference between these two forces, and the direction of the resultant force is along the force that has greater magnitude. Here net force will be 10 Newton minus 4 Newton, 6 Newton, and the direction of the force will be, the box will move to the left. For each of A, B, C, say whether the forces are balanced or unbalanced. If the forces are unbalanced, calculate the resultant force and say how the object's motion will change. So in case A, the forces are unbalanced and the net force is 20 Newton toward right. In case B, the resultant force is balanced. There is 100 Newton toward left and 70 Newton plus 30 Newton, 100 Newton toward right. So forces are balanced. In case C, forces are unbalanced and resultant force is 50 Newton downward. As we have learned that how to calculate resultant force if forces are acting in a straight line. When forces are in different direction, then we have to apply rules for vector addition. And rules for vector additions are draw arrows end to end so that the end of one is the start of the next. Let's say we have to add these two forces 4 Newton and 3 Newton. So 4 Newton acting toward right and 3 Newton acting downward. We will first use a scale of 1 and we will assume that 1 centimeter represents 1 Newton force. So draw a horizontal line of 4 centimeter represent the 4 Newton force. Mark it with an arrow to show its direction. Using the end of this arrow as the start of the next arrow, draw a vertical arrow 3 centimeter long to represent the 3 Newton force. Now complete the triangle by drawing an arrow from the start of the first arrow to the end of the second arrow. This arrow represents the resultant force. Measure the arrow and we have to use the scale to determine the size of the force. So length of line is equal to 5 centimeter. Use a protractor to measure the angle of the force. So angle of force is 37 degree below horizontal. Newton's first law of motion, law of inertia. According to Newton's first law of motion, a body at rest or uniform motion will continue to be at rest or uniform motion until and unless a net external force acts on it. Examples: a book lying on table will remain in a state of rest unless a net force is applied on it, and a ball in uniform motion will remain in motion as long as no net force acts on it. So we can say that any object cannot start, stop or change its direction of motion on their own. Some external force is required to produce such changes, and this tendency of object to resist certain changes in their state of motion or state of rest is known as inertia. So this Newton's first law of motion is also known as law of inertia. Newton's second law states that when a body has a net force acting on it, it is accelerated in accordance with the equation given as force is equal to mass into acceleration, F is equal to ma. M is the mass which is constant for a body, F is the applied force, and A is acceleration caused due to this force F. F and A are both vector quantities, and the direction of the total acceleration vector points in the same direction as the net force vector F. The Newton's second law of motion can also be stated as that the rate of change of momentum of any object is proportional to the force applied for any object of constant mass. Momentum of any object is defined as mass multiplied its velocity, p is equal to m into v. So F is directly proportional to dp over dt, where dp is the change in momentum and dt is the change in time. We know p is equal to m into v. P is again a vector quantity, v is velocity which is also vector. So F is equal to d, you can write mv divided by dt. M is a constant, we can take it out. dv by dt. dv by dt is an acceleration, rate of change of velocity. So F is equal to ma. Force is unit is Newton, mass unit is kilogram, acceleration is meter per second square. These are the SI units. Newton's third law of motion. If two bodies exert forces on each other, these forces have the same magnitude but opposite directions. These are called actions and reaction forces. The two forces that make up a Newton's third law pair have a following characteristics. They act on different objects and act along same line. They are equal in magnitude, they are opposite in direction, and they are forces of the same type. Like we have given example here. When a bullet is fired from a gun, it exerts forward force on the bullet, and bullet exert equal and opposite force on the gun. So this is the action, this force is action, which is accelerating force of the bullet, and the reaction force is recoil force of the gun. Now the question arises here that acceleration will be more. It will be bullet's acceleration or the recoiling gun acceleration. So the force on the gun equals the force on the bullet according to the Newton's third law of motion, and acceleration depends on both force and mass. We know acceleration A is equal to F by m. So in order to keep the magnitude of both force equal, the bullet has a greater acceleration because due to the fact that it has a smaller mass. So bullet's acceleration will be more as compared to the recoiling gun's acceleration. Thus Newton's third law equation states F12 is equal to minus F21, where F12 is the force exerted by the first object on the second in a certain direction, and F21 the force exerted by the second object on the first in an opposite direction. This minus sign shows here that the action and reaction force act in different direction, in opposite direction to each other. Some important definitions we will discuss before going to the next topic. Fluid. Fluid is a substance that is capable of flowing and changes its shape when acted upon by some force, like water, oil, air, all are example of fluids. Drag force. When an object moves through a fluid like air and water, the assistance offered by fluid is called the drag force. It acts opposite to the direction of the motion's object. Drag forces opposes motion, so it tends to slow down the object. It can be reduced by giving the object a streamlined shape. An airplane in flight is acted on by four forces: lift, the upward force; gravity, the downward force; thrust, the forward force; and drag, the backward force, which is also called the wind resistance. Lift opposes gravity and thrust opposes drag. Drag and gravity are forces that act on anything lifted from the earth and move through the air. Thrust and lift are artificially created forces used to overcome the forces of nature and enable an airplane to fly. Terminal velocity. Terminal velocity is the maximum velocity attainable by an object as it falls through a fluid. When the force drag equals the force of gravity, the net force on the object is zero, so the object has zero acceleration. This is a velocity time graph, and the terminal velocity is shown by v. It is a maximum velocity attainable by object. And when object has terminal velocity, its acceleration becomes zero. Motion of a body falling in a uniform gravitational field. Let's consider the motion of a ball falling in a uniform gravitational field. Initially, there is no resistance, drag force is zero, and the only force acting on a ball is its weight. Let's consider 40 Newton is the weight of a ball which is acting downward. As it falls, it accelerates, which increases its speed. As a result, air resistance, drag force increases with increasing speed. And air resistance, let's consider in this case the magnitude of air resistance which is developed is of 8 Newton. Air resistance continue to increases as the ball falls downward. This is increasing. Eventually, this force become equal to the weight of the object. It will no longer accelerate them. At this stage, drag force and force due to weights are equal. So the resultant force is zero, acceleration is zero, and the object or the ball will acquire its maximum velocity. This velocity is called terminal velocity. Ball falls at a steady rate known as the terminal velocity. It will continue with the same speed until it touches the ground. Motion along a curved path, circular motion. Any object moving along a circular path exhibits circular motion. A body moving in a circle changes its direction continuously. Therefore, we said that circular motion is an accelerated motion. And from Newton's law, we know that body can accelerate only when acted upon by some force. So we should understand that velocity is a vector quantity. It has magnitude and direction both. On circular track, the magnitude of velocity doesn't change, but direction keeps changing. So we say that motion is accelerated because there is a change in velocity, not in the magnitude of velocity, but in the direction of the velocity. So in circular motion, the object is acted on by a force at right angle to the velocity. This force is the centripetal force. If m is the mass of the body, then the centripetal force is given by mv square by r, where v is the velocity and r is the radius of the circular track. Examples of circular motions are the boy wheeling a piece of stone around on the end of the piece of string. The tension in the string provides necessary centripetal force. Here, the force of attraction between Earth and Moon provide necessary centripetal force. Here, an aircraft tilts to change the direction. The lift force on its wings provide the necessary centripetal force which keeps the plane on track. Uniform circular motion. Uniform circular motion is motion in which an object travels in a circular path with a constant speed. When a body travels on a circular path, here I repeat this point, its speed is constant, the magnitude of velocity is constant, but its direction changes. Since direction changes, so we call that its velocity is changing. In uniform circular motion, the acceleration of object is always directed along the radius of the circle toward the center. So it is called centripetal acceleration, or it is called, we can call it radial acceleration also. The centripetal acceleration we discuss here, that the centripetal force is mv square by r. So v square by r is the centripetal acceleration, mass multiplied by acceleration. In figure we have shown this is a centripetal acceleration and centripetal force. In figure we have shown that centripetal acceleration and centripetal force directed always toward the center of the curve, toward the center of the circular track. This is the direction of motion. Then velocity vector is perpendicular to the force vector, and this radial acceleration is perpendicular to the velocity component, but tangential acceleration is along the direction of motion. So tangential acceleration causes change in speed of object. Tangential acceleration is responsible for change the magnitude of velocity. Since we are studying here only the uniform circular motion, so we will not discuss in detail here. Just a point for you that in non-uniform motion there is a tangential acceleration also which causes change in speed of object. Uniform circular motion. Uniform circular motion is motion in which an object travels in a circular path with a constant speed. I'll again repeat this point, that when a body travels on a circular path, its speed is constant, but its velocity changes. Means the magnitude of velocity remains constant, but there is a change only in the direction. At every point, the direction of the object is moving during the circular motion. In uniform circular motion, the acceleration of object is always directed along the radius of the circle. It is called radial acceleration also, or we call it centripetal acceleration. The centripetal force is mv square by r, where v square by r is the acceleration. So the centripetal acceleration is v square by r, and this is a tangential acceleration we have drawn here. Tangential acceleration is along the direction of motion. In non-uniform motion, there is a tangential acceleration which causes change in speed of object. Since we will not discuss here non-uniform motion, we will discuss the uniform circular motion. But this is the reason that tangential acceleration causes change in speed during circular motion. But we will study the centripetal acceleration, which is radial acceleration. Momentum. The momentum of an object is defined as a product of its mass and its velocity. Momentum is a vector quantity. It has magnitude and direction both. Now we know that acceleration A is equal to change in velocity divided by time. V is the final velocity, let's say, and U is the initial velocity. So force is equal to mass multiplied by acceleration. So we can put the value of A here, m multiplied by V minus U by t. Now Ft is equal to mv minus mu. Ft is known as impulse of force. Mv is the final momentum of the object. Mu is the initial momentum of the object. So mv minus mu, change in the object's momentum. Impulse of force is equal to change of momentum. It's a very important relationship between impulse and change of momentum. Momentum conservation. When two objects interact, the vector sum of total momentum before they interact is the same as the vector sum of the total momentum they possess after interaction. So total momentum before collision is equal to the total momentum after collision. Now we are given a situation here where the collision of two objects has been discussed, and the value is given that initially m1 object has some velocity u1 and m2 object was at rest. So total momentum before collision is m1 u1 plus m2 u2, where u2 is 0. So m1 u1 is the total momentum before collision. After collision, the situation is given here. M1 and M2 both objects will move in the opposite direction. So after interaction, M1 V1 plus M2 V2 is the total momentum. Now the direction of M1 object is opposite to the direction of M2 object. So we will write minus M1 V1 plus M2 V2. You will understand when you solve some problem based on principle of conservation of momentum. So here we have discussed some problem, and here the mass of racket and ball is given. The initial velocity of racket is 25 and ball is at rest. After, when the racket hit the ball, so what happens that racket lose some momentum and ball gains some momentum. So here the data is given that the mass will be unchanged for both racket and ball, and velocity becomes 15, and what will be the velocity of ball then? So we will calculate using the principle of conservation that total momentum before interaction equal to total momentum after interaction. So before collision, racket momentum is mass multiplied velocity 50 meter per second, and ball's momentum is 0 since ball is at rest. After collision, racket's momentum is 50 multiplied by 2, 30 kilogram meter per second. Momentum gained by ball is equal to the momentum lost by racket. So the ball's momentum will be 50 minus 30, it is 20. Now let's say the ball's velocity is Vb, so mb Vb is equal to 20. So Vb is equal to 20 divided by mass of ball, it is 80 meter per second. So this is the way we calculate and we solve problem based on principle of conservation of momentum. I hope that you like this video. Please write your feedback. Thank you very much for watching this video.